All right, I need to take a look at problem number 9 on section 1.3. So here's the situation. You've got a round object sitting in this trough. They give you the diameter here as 1.5. They give you the distance across the point to point there is 1.7. If you extend these sides down, they'll make a 30-degree angle at the bottom. And what we're looking for is the distance that the circle sticks above this edge here. And we assume this edge and that edge are at the same elevation. Okay, so how are we going to do that? Here we go. First of all, they tell us the diameter was 1.5. So if I divide by 2, that's 1.75 to be the radius. So from the center of the circle, if I draw a line out to this point of tangency here, I like points of tangency in circles because that's where a radius and a tangent line will be perpendicular to each other. Okay. So I know that that radius is 0.75. Right, let's see if I make this a little bigger. Maybe I can work this. So that was 0.75. Okay. What I want to do here is I want to draw this line, this vertical line that the book has it drawn in. Draw it all the way down. I have these two edges extended down to where they would meet. They told me the whole thing was a 30-degree angle, so this right here would be a 15-degree angle. 15, I said 15, but I wrote 50. This would be a 15-degree angle. Okay. Now, I think if I were to extend this up here to the same level as that, I have another right angle. The thing I'm looking for is this length here. That length there is what they call D. Right? The thing is, I think I can find D if I can find this length, which I'm going to call, for the lack of anything else here, X. Right? Because D is going to be the radius minus X. And I think I can find X because why? Because X is going to be the difference between the distance all the way from here down to this point and from here down to that point. And I have two triangles, two right triangles that have those in it. For instance, this 0.75 is this length here. I've got a 15-degree angle, and I'm looking for that length right there. In fact, let's color code this here. Let's do this in red. So that length right there is going to be calculated in red. The thing is, we'll call that Y. That is 0.75 divided by Y is, that would be the opposite side divided by the hypotenuse. So that's the sine of 15 degrees. Solving for Y, I've got Y equals multiplied by Y divided by the sine there. So 0.75 divided by the sine of 15 degrees. Okay. Then I look at a bigger triangle and say I can calculate, let's do this in green, I can calculate this side all the way down from here all the way down to the bottom because I know the side up on the top here. The side up on the top here is half of the 1.7, which would be 0.85. So this length across the top here is 0.85. So I've got this triangle here now using the 15-degree angle and a right angle there. So I can use, I think, the tangent to calculate that green side. So we'll call the green side, I don't know, Z, right? Just to pick a letter. Because 0.85 divided by Z, that would be the opposite to that 15-degree angle and adjacent to the 15-degree angle. So 0.585 divided by Z is the tangent of 15 degrees. Okay, solving for Z, I've got Z equals the tangent of 15 degrees. Right. This now lets me find x, because x was going to be the difference between z and y, the green line and the red line there. So x is equal to, sorry, did I do that right? I didn't. What the heck am I doing here? Sorry, my algebra's a little sloppy there. Let's go back to green. I'm going to multiply by z and divide by the tangent. So z equals, where was I? Let's come back here. Multiply by z, divide by the tangent. Does that look a little better? Z is 0.85 divided by the tangent of 15. Good. Now, x is the difference between z and y. So it's 0.85 over the tangent of 15 degrees minus 0.75 over the sine of 15 degrees. Now that I know x, I can find d, because d is just going to be the radius minus x. So d is equal to the radius of 0.75 minus all of this stuff. Wow, we made it. The thing that you're really looking for on any of these problems is you're trying to figure out, you're trying to find right triangles where you know an angle and you know a side, right? Circles, you probably want to draw a radius into where you got a tangent line, because then you've got that right angle. That's going to let you get a triangle. I happen to notice also on this one that I've got another right angle by going all the way up to the top and over, because I knew something about that distance across. So I knew this side length, I knew a right angle there, and I knew the 15-degree angle down here. That's going to let me get some other sides, right? Anyway, there you go. That's number 9 on section 1.3.